Alright, now we're going to do experiment 16, which is an oxidation reduction titration. In this oxidation reduction titration, we're going to use the dichromate as potassium dichromate, and we're going to have iron in the form of an iron oxide unknown. And the products of this, so you have iron plus 2 is going to go to iron plus 3. The dichromate ion is going to go to iron, or to chromium plus 3. Alright, so I've already balanced it. I'll go through the steps. First thing you have to do is get the oxidation numbers. If we look at the dichromate, each oxygen is -2, oxidation state. And so 7 of them give you a -14. The overall charge is -2. And so the 2 chromiums must be +12. Therefore, each chromium has an oxidation number of +6. The other 3 are very simple. Iron plus 2 has an oxidation number of +2. Iron plus 3 has an oxidation number of +3. And chromium plus 3 has an oxidation number of +3. So I draw my arrows, and I see that my chromium, my dichromate, at a chromium of +6 is going to a chromium of +3. So that means that I have to gain 3 electrons per chromium. So each chromium has to gain 3 electrons. In the dichromate, I have 2 chromiums. And so I have to gain 6 total electrons. And so I have to have 2 in front of my chromium plus 3 because I have Cr2 on this side. And so I need 6 electrons. Alright, and so when you go from a chromium of +6 to a chromium of +3, that is a reduction half reaction, which makes the dichromate the oxidizing agent. Alright, and so for the iron, much simpler. You're going from iron plus 2 to an iron plus 3. That means you have to lose 1 electron for each iron. And for the electrons gained, +6 electrons, to equal electrons lost, we have to do the iron plus 2 to iron plus 3 6 times, so that we have 6 electrons gained and 6 electrons lost. Alright, and then the iron going from iron plus 2 to +3, that is an oxidation, which makes the iron plus 2 the reducing agent. Alright, and once we balanced our electrons gained, electrons lost, then we do the overall charge. Alright, so the overall charge of the dichromate is -2. Now we have 6 iron plus 2s. That gives you a +12. And so the overall charge on the left side is a +10. When we go to the right side, we have 6 iron plus 3s. For a total of +18. We have 2 chromium plus 3s for a total of +6. So on the right side, we have a total of +24. And so we have a +10 and a +24. We are doing this oxidation reduction titration in acid. And so to have the charge on the left and right be the same, we have to have 14 H pluses on the left. So when I put my 14 H pluses on the left side, now I have a total charge of 24, which is equal to the total charge of 24. And so now we've added hydrogens, 14 of them, and to balance those hydrogens and the 7 oxygens from the dichromate, on the right side we add 7 H2Os to give us 14 hydrogens and 7 oxygens on both sides. So there is our balanced oxidation reduction reaction. Alright, so we're doing a titration, and so for a titration, mV over C is equal to mV over C. But our iron, we are going to calculate the mass of iron by taking the mass divided by the molar mass. So molarity times volume, moles per liter times liters, that gives us moles. If we're going to do a mass divided by molar mass, that also gives us moles. And so in the numerator, It is moles on the left and moles on the right. For a titration, you have to then divide by the coefficients. All right, and so when we are looking at our dichromate, all right, I have started the experiment, and so to find the molarity of the dichromate, you take the mass divided by the molar mass. So I've already weighed out the dichromate, and I used 0.2544 grams. I divide that by the 294.184 grams per mole, and I put this in a 100 milliliter volumetric flask, and so in liters that is 0.1 liters. And you will get, when you do this division, you will get your molarity to 4 significant figures. Now, when we're doing our titration, we will get our volume of our dichromate from the titration. Now, since we don't have a volume on both sides of this titration equation, because we're having a mass and a molar mass on the side for the iron, you must have your volume of dichromate converted to liters. And your coefficient for your dichromate in our balanced chemical reaction is 1. There's a 1 in front of the dichromate. There's 1 dichromate. Now, when you look on the right and you have your coefficient of your iron, that is a 6. And so your coefficient for your dichromate is 1. Your coefficient for your iron plus 2 is a 6. The mass of the iron plus 2, which is also equal to the mass of your iron, this is what we're calculating in our titration equation. All right, and your molar mass of iron plus 2 is the molar mass of iron on the periodic table, 55.854 grams per mole. All right, so what we're going to do is we're going to take our iron oxide, and our iron oxide is going to be, I should probably have X and Y by the iron and the oxide. So it's an unknown. It's not pure FeO. It is some number of iron, some number of oxygens in our unknown iron oxide. We are going to add hydrochloric acid, 6 molar hydrochloric acid, and it's going to dissolve our iron oxide, because that's going to give us iron chloride and water. And so if we do the molecular, then we do the ionic. All right, iron oxide is insoluble. It's a solid, and so it stays as a solid. We're going to have to heat this up in order to get this to dissolve. All right, and so we have the H plus and the Cl minus, because strong acid HCl breaks into ions. All halides are soluble except for silver, mercury, lead. So iron chloride is soluble, iron plus 2 and 2Cl minus. And then liquids and solids all stay together, and so H2O stays together as a liquid. And so the 2 chlorines cancel out, and so our net ionic is our iron oxide is going to react with our acid to give us the iron plus 2 and water. So all of our iron that we get in this reaction came from our iron oxide. Now, when we have our iron oxide unknown, some of that iron is going to be in the iron plus 3 oxidation state. So before we can start our titration, we have to convert all of the iron plus 3 into iron plus 2. And so to do that, we add a 10 plus 2. And so this is another much simpler oxidation reduction reaction. And so we need to reduce our iron plus 3 to iron plus 2. And so we add the oxidizing agent 10 plus 2. And so or the reducing agent, the reducing agent 10 plus 2. So 10 plus 2 is going to oxidize into 10 plus 4. So when the 10 plus 2 is doing an oxidation, it is a reducing agent. It is what we add to reduce our iron plus 3. All right, once we get our mass of iron from our titration calculation, we take the mass of iron, divide by the mass of iron oxide, multiply by 100, and we will get our percent iron in this iron oxide unknown. So I have started the experiment already. I am finished with runs 1 and 2. Here are the data. So the data Run 1, I used 0.1238 grams of iron oxide. The unknown number is 51. I had an initial reading of 0.02, a final reading of 24.92, and the volume that was required to do this titration was 24.90 milliliters. For run 2, since I almost used up the entire amount of my burette, I added less. I added 0.1003 grams of iron oxide, number 51 unknown. And my initial was 0.05 mils. My final was 20.75 mils. In order to do the titration to the end point, it required 20.70 milliliters. I have weighed out 0.1150 grams of iron oxide number 51, and here is the experiment. All right, and so here I have my iron oxide that is in the flask. This is the 0.1150 grams of my iron oxide. All right, so now we're going to add 20 mils of acid. So here is my 6 molar HCl. And so I add 20 mils of 6 molar HCl. And it is not going to dissolve. It may dissolve over a long period of time. But in order to get this to dissolve quicker, we are going to heat it up on our hot plate. So here I have a hot plate, and I'm going to heat it up. And so you see that this is an opaque. You can see some of the solid on the bottom. We do not have a clear solution. This is an opaque. It is not homogeneous. It is solid and liquid. And so we're going to heat this up to dissolve it. All right, and so I'm going to, in the meantime, get my mercury chloride, 5 mils of mercury chloride ready. All right. Got my 5 mils of mercury chloride ready to go. I'm going to get my acid solution ready to go. I need 25 mils of this later. All right. And I got, so I had my dichromate, my primary standard potassium dichromate, and on the board I already put the mass. It was a 0.2544 grams, and then I quantitatively added that to the 100 ml volumetric flask, and then I filled it up to the mark, and then I poured that into the beaker here. Rice rinsed my burette, filled the burette with the dichromate so that it is ready for the titration. The initial dichromate is 0.00. And so for run 3, again, we have 0.1150 grams of iron oxide number 51. And then the initial reading is 0.00 mils for our dichromate. All right, and so soon our iron oxide with hydrochloric acid is going to be boiling. And I will carefully swirl that. All right, and it will eventually clear up, which means that it has all dissolved. All right, so once we get a clear solution here, we're going to add our tin plus 2. So here we have our solution of stannous chloride. It is SnCl2, and I'm going to add that to the solution once that dissolves until it turns into a colorless or a light green solution. And then once I have done that, I'm going to cool it down to room temperature, and I'm going to add some mercury chloride, mercury 2 chloride. And that is going to stabilize any of the extra Sn plus 2 that I have added in getting this to become a clear solution. All right, so here we have some boiling going on. I'm going to turn down the heater. And you can see that it is clearing up. Heat it a little more. But that looks pretty good. Looks like it is all dissolved. I don't see any solid in there anymore. It has all dissolved. All right, so now we're ready to add our drops of tin chloride. All right, and so we're going to have to add tin chloride until this solution becomes colorless. And we don't want to add too much extra tin chloride. So we'll put in a few drops, give it a swirl, put in a few drops, give it a swirl, put in a few drops, give it a swirl, put in a few drops, give it a swirl. All right, so now we have a colorless solution. And so now we are ready to cool this off. And so I have some cold water here. I'm going to get a couple more ice cubes. And I'm going to cool this off. So I put it in a cold water bath. And I'm going to cool this off until it gets back to room temperature. Turn off my hot plate. It's still a little warm. I want to get it to room temperature. I don't want to get it too cold, I just want to get it to room temperature. Alright, so that's good. We're right at room temperature here. I don't feel it as colder or hotter than air. Alright, so now I'm going to add this mercury chloride. So there is some silky white precipitate in here. So we're going to let that set for a little bit. All right. So we cooled it to room temperature. We added the 5 mils of the mercury chloride, mercury 2 chloride. And we have our silky light precipitate. Now we're ready. We're going to let it stand for a little bit here. And then we are ready to add 25 mils of an acid mixture. So this is a sulfuric acid, phosphoric acid mixture. We got 25 mils of that we're going to add. And then we're going to add our DAS indicator. And then we're going to titrate it with our dichromate. And so the titration reaction produces green chromic ions, the Cr+3 green chromic ions. When the solution is going to go from clear green to a blue-green, then we are near our endpoint. And then the endpoint is signaled by a sharp change to a purple or a violet blue color. All right, so now we're ready to add our acid solution. And then our 6 drops of our DAS indicator. And then we're ready to do our titration. Alright, so it's turning a greenish color. Getting a darker green. Color's lasting a lot longer when it hits the green now. We're getting close to the end point. Start adding it dropwise. It's getting really close to the end. Ooh, that was close. One drop should do it. All right, so one drop turning purple, and our final volume is 23.49. And that is the titration of the dichromate with the iron oxide.